similarities and differences between the different types of coding languages. Are all programming languages really that different, or are they more similar than we think? Hello everyone, welcome back to the channel. I hope you're all doing super well. Yesterday we had some fun with a Wordle challenge, but today we're switching gears to something a little different and just as exciting. In this video, we're diving into the world of programming languages. We'll explore some of the most popular ones, talk about how they're similar, and highlight the key differences that make each one unique. If you missed yesterday's Wordle video, feel free to check it out later. But for now, let's jump right into the fascinating topic. Programming languages let humans communicate with computers by turning ideas into machine commands. Without them, we would need to use binary code, which is difficult for humans. They evolved from low-level languages to high-level languages. High-level languages are more abstract, user-friendly, and closer to natural language. This evolution made programming more accessible, efficient, and powerful. They enabled the creation of software, websites, mobile apps, robots, games, and AI systems. Programming languages are the backbone of the digital world, transforming creativity and problem solving into digital solutions. Now, you may be wondering why so many programming languages actually exist. No, single language solves every problem. Each has unique goals and trade-offs. Some are domain specific, others general purpose. Languages follow different paradigms, object-oriented, functional, or procedural. New technologies drive new languages. Examples Swift for iOS, Go for scalability. The variety of languages creates flexibility, innovation, and better tools for different needs. The chart on the left has four different types. Low-level languages, which are close to machine code, hardware specific. Some of the examples they might use low-level languages for are assembly and machine code. High-level automates Cactus, runs with a compilation. Query languages used to retrieve, manipulate data or slash manipulate data. Markup style languages, which are defined structures and presentation. So this chart provides an overview of four main types of programming languages: low level, high level, query, and markup and style. It outlines their definition, example, common use cases, and key insights. The color-coded layout makes it easy to compare how each type supports different aspects of software development, data handling, and web design. Now, you may ask which programming languages are actually popular. Here's a detailed list. So, programming languages are not one size fits all. Each is designed with specific goals: speed, simplicity, data analysis, web development. No single language dominates every field of technology. This section explores 20 popular programming languages. Focus is on application, importance, and limitations, not just name and date. Guiding questions will cover strengths, industries, slash companies using them and relevance. Collectively, these languages power modern software, OS mobile apps, AI cloud, and web platforms. So on the left side, we have Python, JavaScript, Java, C, C++, C Sharp, PHP, Swift, Kotlin, and Go, as also Golang. On the right side, we have Rust, R, SQL, TypeScript, Ruby, MATLAB, Scala, Perl, Haskell, and Dart. So these are the 20 popular programming languages. So Python is a high-level beginner-friendly programming language known for its simple syntax and versatility. You may be asking, where is Python used? Python is used in web development, data science, AI, automation, and large-scale applications. Why it's important? Its simplicity, rich libraries, and storing community make Python ideal for diverse tasks. Big companies slash products that use it. Google, YouTube, Instagram, Spotify, Netflix, Dropbox, Reddit, and NASA are all big companies that use Python. The limitations with Python, so Python is slower, memory heavy, has limited mobile support, and faces GIL and runtime error issues. JavaScript, on the other hand, it's a high level language used to make websites interactive and dynamic. Web development, mobile apps, games, and server side applications use it. It powers interactive features on the web and is essential for modern websites. Google, Facebook, Netflix, LinkedIn, and PayPal are all big companies that use JavaScript. Some limitations with JavaScript: it has security risk, slower than compiled languages, and browser compatibility issues. Java is a high-level object-oriented platform independent programming language. Web apps, Android apps, enterprise systems, cloud, and big data. Why it's important? It's portable, secure, and widely used for building scalable applications. Amazon, Netflix, Uber, Airbnb, Android apps are all big companies that use Java. Some limitations is that it's slower than C++, higher memory use, and verbose syntax. A powerful low-level programming language known for speed and system. A powerful low-level programming language known for speed and system. Where is C used? Operating systems, compilers, databases, embedded system, and game engines. Why it's important? It provides efficiency, control, and portability, forming the base of modern languages. Big companies slash products that use it: Microsoft, Google, Intel, Apple, and Linux OS. Some of the limitations are that no object oriented features, manual memory management, no built in exception handling, and a limited standard library. C++. It's a fast object oriented programming language extended from C. Games, operating systems, browser, embedded systems, and high performance apps use it. It combines speed with OOP, ideal for large scale complex software. Microsoft, Adobe, Google, Apple, Amazon, Epic Games are all big companies that use it. Some limitations would be that it has complex syntax, manual memory management, and slower compile times. Now we come to a major one that we're all learning as college students, C Sharp, a modern object-oriented language by Microsoft, part of the .NET ecosystem. Where it's used? Web, desktop, mobile, cloud, and game development. Why it's important? It's versatile, type safe, and tightly integrated with .NET for scalable apps. Microsoft, Stack Overflow, Alibaba, Intuit, Unity Games are all big companies that use it. The limitations are it's less controlled than low level languages, slower for system level tasks, and mostly tied to .NET. PHP. PHP is an open source server side language for creating dynamic web pages. Where it's used? Mainly used in web development within HTML. It's widely used, easy to learn, and powers platforms like WordPress, Wikipedia, and many web applications use PHP. Can be slower than modern alternatives and may have security risks if poorly coded. Swift is Apple's modern language for iOS and macOS app development, used to build apps across Apple platforms. It's fast, safe, and beginner friendly for Apple app development. Apple, Lyft, Airbnb, LinkedIn, and many iOS/Mac OS apps use Swift, limited to Apple ecosystems with fewer libraries than older languages. Kotlin is a modern statically typed language fully compatible with Java and runs on the JVM. Where it's used, mainly used for Android apps, but also for server side and cross platform development. Why it's important? It's concise, safe, and officially preferred by Google for Android development. By companies, big companies slash products that use it, Google, Pinterest, Trello, and many Android apps use Kotlin. Some of the limitations are that it's slower compilation than Java and a learning curve for developers new to its features. Go, also known as Golang. Go is an open source statically typed language by Google designed for simplicity, efficiency, and concurrency. Where it's used? Mainly used for backend development, cloud services, and distributed systems. Why it's important? It's fast, easy to learn, and handles concurrent tasks efficiently for server side apps. Big companies/slash products that use it: Google, Dropbox, Uber, Docker, and other cloud platforms are all using Golang. Some of the limitations with Golang are that it has limited genres, fewer libraries than older languages, and minimal GUI support. Now, with the other 10, Rust, R, SQL, TypeScript, Ruby, MATLAB, Scala, Perl, Haskell, and Dart are modern or specialized programming languages, each with distinct advantages. Rust is designed for safety and high performance, making it suitable for system level programming. R is commonly used for statistical analysis, data visualization, and data science tasks, while SQL is essential for handling and querying databases. TypeScript adds static typing to JavaScript, helping developers write more reliable code. Ruby is a simple and elegant language often used in web development with Ruby on Rails. MATLAB is focused on numerical computing, simulations, and engineering applications. Scala combines functional and object oriented programming, frequently used in big data projects. Perl is a versatile scripting language, popular for text processing and automation. Haskell is a purely functional language, emphasizing concise, safe, and reliable code. Lastly, Dart, developed by Google, is mainly used with Flutter to build a cross-platform apps for mobile, web, and desktop. All programming languages, no matter how different they may seem, are built on the same core ideas that allow them to give instructions to a computer. They're used to express algorithms, step by step solutions to problems by relying on logic such as conditions, if else, and loops for, while, to guide how a program runs. Each language also follows a specific syntax or set of rules that determines how code must be written so the computer can interpret it correctly. This includes how variables, functions, and statements are structured. Additionally, every language provides ways to represent and work with data through common types like numbers, text, and true and false values, as well as tools to store and organize that data, such as variables, arrays, and objects. Level of abstraction. So, low level languages, example, which is assembly, closer to machine code, give precise hardware control, very fast but harder for humans to read slash write. High level languages, example Python and Java, more human friendly and easier to learn, but require transitions before running on machines. Execution model, compiled languages like C, C++, code is converted into machine instructions before execution, making them faster. Interpreted languages like Python and JavaScript run line by line through an interpreter, easier to use across systems but usually slower. And lastly, programming paradigms. So procedural step by step instructions, example C, object oriented, which is the OPS, code built around objects and classes. So programming languages like Java and C++ use object oriented. Functional, so uses functions and avoids changing data. So example would be Haskell programming. And then scripting, often for automation or web tasks, usually interpreted. So similarly, as we mentioned above, Python and JavaScript would use scripting. Now, you may be asking, which programming language should you learn first? The best programming language to start with really depends on what you want to achieve and the areas of technology that interest you. If your goal is to pick a language that is both beginner friendly and wildly applicable, Python is an excellent choice. It's known for having a simple and readable syntax, which makes it easier for newcomers to focus on learning how to think like a programmer rather than struggling with complicated code structures. Beyond being easy to learn, Python is also very flexible. You can use it for web development, analyzing data, building machine learning models, or even automating everyday tasks. This broad range of applications is one of the main reasons Python is often recommended as a first language. Now, the future of programming languages. The future of programming languages is shaped by emerging technologies and evolving developer needs. AI and machine learning will keep Python at the forefront due to its rich ecosystem, while new AI focused languages like Mojo may gain popularity. Performance in systems programming is driving interest in Rust and Go, valued for their speed, safety, and efficiency in cloud native and performance critical tasks. In web development, JavaScript remains dominant, with TypeScript growing as a scalable option for large projects, supported by a rapidly evolving ecosystem of frameworks and tools. For mobile and cross platform development, Kotlin and Swift continue leading in their respective ecosystems, while cross platform frameworks provide flexibility for building apps across multiple devices. To sum up, even though coding languages vary in their structure, difficulty level, and intended use, they all serve the same purpose of letting people give instructions to computers by understanding what makes them alike and what sets them apart. Programming Programmers can make better choices but about which language to use in different situations, whether it's for secure systems, interactive websites, or advanced AI projects. Since technology is always changing, it's important to keep learning and remain flexible. Exploring different languages not only strengthens problem solving abilities but also creates more opportunities for growth and success in programming. That's it for today's video. I hope this breakdown gave you a clearer picture of the similarities and differences between programming languages and maybe even inspired you to try out a new one. Remember, every language has its own strengths, so the more you experiment, the more you'll discover what works best for your style and goals. If you found this helpful, don't forget to hit that like button, subscribe, and tap the bell so you never miss a new video notification. And hey, drop a comment down below and let me know which programming language you're currently learning or thinking about starting. Thanks so much for hanging out with me today. And as always, keep coding, keep learning, and I'll catch you in the next one.